All right, so now let's look at an additional example aside from those examples I have already delivered in my general video lesson on integration by parts. And so it is intended that this video lesson, short one on this particular example, is to be viewed after you have already viewed thoroughly my main general video lecture for integration by parts, because that's where all the techniques or the fundamental of the integration by parts was there. And here it's just only an additional example. And somewhere along the way or near the end of the example here, I should be able to also point out what's special about this particular example that I brought up right there. So here we go, let's get into it. And so in this example, let me bring up a problem where we want to evaluate the indefinite integral. And of course, so it is here, and in most of my video about the examples for integration by parts, I will mostly focus on the indefinite integrals. And so here we would like to find the indefinite integral for the simple function natural log of x. Okay, and of course there is that dx component right here. All right, and so once you have already watched my main general video lecture on the integration by parts technique, then I brought in a guideline that's so-called the Liate guideline right here. This is a guideline that we used to pick a U choice, because picking a U choice is the main theme, the biggest step in our integration by parts work right here. Okay, and so, but then when we're looking at this problem, it is surprisingly simple. The problem here is a little bit too simple. It's too simple in a sense that, hey, back in those examples that I deliver in the main general lecture, then those functions that we were integrating there had a clear product of two separate functions that came out from any two different families of algebra, and that was where the Liate guideline was so useful back there. Because there, within those video lectures, within those examples, then you were able to see clearly there's one function here being in a product with another function, and including being in a product with this dx. But here we only have one function, so we don't clearly see the product of two functions. We only see one function. Okay, so that's kind of making it hard for us to choose to make any of us who are about to do this problem worry. Okay. But no worry, we are still going to see how useful this Liate guideline is going to be. Because here, so in my advice right here, and this advice comes out from my teaching experience. So if we strictly stay with the Liate, and of course, what I said in the video lectures, in the main general lecture, that there are exceptions to the Liate, what I said there is still correct, it's still true, but I would like to emphasize that this problem we can still stay with the Liate guideline. Okay, so really let's get to it. The idea now is that I am going to purposely see the natural log here as, allow me to draw a little arrow indicating that natural log itself can be seen as natural log, but in product with 1. And of course there's that product with the dx expression. All right, so now aside from the dx differential here, then now all of a sudden we realize we still have two functions. Natural log of x is a function. That came out and apparently came out from the logarithm family. And the other function. See, algebraically or usually we never have to bother writing whatever the function times 1, but in this special case right here, we purposely rewrote this expression at start of ours into a product of 1 times our main function. So now we can see that the other function is a constant. Think of that as an f of x equals 1 right here. It's a constant function, and constant 1 right here. But now this constant function is clearly a member among the algebraic functions family, because this function here being a constant function, it is a power function, power 0. 1 is the same as x to the 0. We have learned that all over in our differential calculus class, like that. Okay, and so any constant function can be regarded as one function among the algebraic family. So now, as we get to this point, and now we clearly nail down, our natural log of x came out from the logarithm family, and our constant function 1 here came out from the algebraic family. Then now we have a clear direction of how to make a good u choice. So I would now say I'm going to let u equal natural log of x. Okay, and so in that way, my derivative of u du dx is going to be equal 1 over x. And this is a good review for your differential calculus right here. And this will lead to, I can now multiply the differential dx to both sides of my current equation. And so what I was in the middle of saying, now this equation leads to du equal 1 over x dx. Okay, and so now once we've made our u choice, then we arrived at du equals 1 over x dx. And then on the other hand, right at that instance where we made our u choice right there, then in this entire product, including the function, the other extra function, and then the dx here, then everything else aside from what we chose in this product to be u, and everything else 1 times dx, all of that is regarded as a dv, just like how I explained that back in the general lecture on the integration by parts technique. All right, and so now once we've had once we recognize this 1 dx right here as a differential dv, then we can find v here. We can find the function v by simply integrating. Take the indefinite integral of this 1 dx, or just simply dx. Okay, but for safety, I'll just write 1 dx. And so that means our v function now equals x. And again, all of the reasoning was given back in the general lecture. So in this little integral, indefinite integral, we can skip the plus c here. So once in a rare while, once in a few whiles, then we can skip that plus c right there. Okay, so now we are ready to advance to the next step. Allow me to remind the formula of the integration by parts again. So as long as we can recognize our starting problem to be in the form of a u times dv, then we can proceed by, and assuming that you have already found out what u was, you made your u, and then assuming you already found your v, then this integral will equal to u times v. Okay, and then subtract whatever comes out from the integral v du. Okay, so again, I am highlighting the important formula for the integration by parts technique. All right, so in this case, and again, back to the problem, we have successfully recognized the starting integral as a udv, so we don't have to rewrite that udv here. I'm just getting straight into the problem. Our starting problem was a udv, so it's natural log of x dx, our starting problem. Okay, and so, but it will equal to u times v. So u was our u choice, and v was what we found. So let's now put the pieces together. Okay, and so now when we're putting that in, we're looking at x times the natural log of x. Okay, and then now I'm about to produce that extra integral according to the formula for integration by parts. So this extra integral has the form of v du, v times du. Okay, and so again, remind ourselves, v was x. Okay, but du was that 1 over x dx. Okay, and so in that way, now I'm looking at x times 1 over x dx. That's substituting in for the du. Okay, And so algebraically inside of this integral, this indefinite integral, before we're attempting to get that, then we can cancel out the x's there. And so one more step before we formally find the indefinite integral of that here. So this first term stays the same because there isn't anything else to be done with that. But now the integral here becomes the integral of just simply 1 dx again. Okay, or just when you get mature enough in math, this is just simply the integral of dx. Okay, we can just simply skip it like that. Okay, and I had a video clarifying the meaning of the symbol, the integral sign and the dx. It means 1 times dx. All right, and so now our answer is ready. First term, there isn't much to be done, so I'm leaving that the same, x times natural log of x. But the next term is the answer to this integral. So 1 dx, and as we're integrating it, it becomes just simply x according to the power rule. And now this final answer needs to have a plus c because this is our ultimate antiderivative that we were looking for, our main antiderivative we're looking for. Okay, and so this is now going to be our final answer. However, before any one of you close down or any of you be done with this example, then I highly recommend that you pause the video, okay, and apply your skill in taking derivative to verify that we have found the correct antiderivative of our problem. So our starting function here is natural log of x, and now I say that this x, natural log of x minus x plus c, is the antiderivative or the indefinite integral of this natural log of x function. Okay? All right, and so now once we have checked and verified that we have found the answer to this starting function, then what's special about this example that I brought up, as a separate example aside from those examples being delivered in my general lecture? Now, it's special in what I explained earlier. Usually, when we're about to apply the Liate scheme, this Liate guideline, we tend to expect that the big function that we're integrating here, that we're trying to find the indefinite integral, appears in the form of a product where we see clearly two functions. One of them comes out from this family and one will come out from another family. This function has only one function. I mean, this problem has only one function in the whole product. And so the specialty and the special technique, the special treatment we applied here is that we purposely, and sometimes we can do that. I mean, we don't always do that. Doesn't always work, but we're doing math, so be open to different creativities. Okay, so we purposely saw this as a product of 1 times natural log of x. And so the special part is here where we, from being one function, but we purposely re-expressed that as a product of two functions, where we can recognize one of them came out from the Liate, one of the function families, right? And then the other one is a different family, the different function family. And then now we can align ourselves with the Liate guideline right there, and then get the problem done. Okay.